Since 1750 BC, humans have been obsessed with chocolate, first as medicine, then as a sacred ritual. Today, it's a global addiction, with 100,000 bars eaten every second. But how do we turn a bitter tropical fruit into the smooth bar in your hand? Let's look at the massive world of industrial chocolate production. 3,000 years ago, Mayans and Aztecs discovered something extraordinary inside colorful pods growing from tree trunks. They created xocolotl, bitter water, so valuable that they used the beans as currency. Imagine paying for groceries with chocolate. Spanish conquistadors brought it to Europe in the 16th century with one game-changing twist: add sugar. But chocolate remained a luxury only the wealthy could afford. The Industrial Revolution changed everything. Today, we produce 7.5 million tons annually, a $130 billion industry. A single factory can produce 2 million bars daily. So how do we get from a remote tropical farm to millions of identical bars on supermarket shelves? Let's find out. Our journey begins in the Cocoa Belt, 20 degrees north and south of the equator. West Africa supplies 60% of the world's cocoa, but these trees are incredibly demanding. Here's what's strange. Cocoa trees cannot survive direct sunlight. They need shade from taller forest trees, even weirder. The football-shaped pods sprout directly from the trunk in a phenomenon called caulifloring. Each tree produces only 20 to 30 pods yearly, and each takes 12 months to mature. Farmers use machetes to cut ripe pods without wounding the tree. One careless cut can kill a tree that took 5 years to start producing. Crack open a fresh pod, and you won't find brown beans. You'll see 30 to 40 purple or white seeds, surrounded by white, slimy pulp. To make 1 pound of chocolate requires 400 beans, roughly 12 pods. When a tree only produces 30 pods per year, you understand why chocolate was once so expensive. But harvesting is just the beginning. Within hours, farmers pile the freshly opened beans onto banana leaves, covering them to create a hot, airless environment. For 5 to 7 days, natural yeast and bacteria feed on the pulp. Temperatures soar to 50 degrees Celsius, but fermentation does something crucial inside the beans. It triggers hundreds of biochemical reactions that create over 600 flavor compounds. Without fermentation, you cannot make chocolate. The beans would taste purely bitter, with no chocolate character whatsoever. Farmers turn the pile daily. Watch the beans transform from purple to brown. That chocolate aroma emerges for the first time. Next comes sun-drying on bamboo mats for 5 to 14 days. Moisture must drop from 60% to just 7%. Too much moisture means mold during transport, ruining flavor and creating dangerous toxins. These farmers, earning just a few dollars daily, are performing the most critical quality steps in the entire process. Their decisions determine the chocolate you'll taste 6 months later, 5,000 miles away. The beans are packed into 60-kilogram jute sacks and begin an epic journey. Trucks to ports, then shipping containers carrying thousands of tons across 3 to 4 weeks at sea. At the factory, inspectors randomly sample bags, checking moisture content, fermentation quality, and defects. Moldy, insect damaged, or poorly fermented beans. The entire shipment gets rejected or discounted. Accepted beans sit in climate-controlled warehouses at 18 degrees Celsius until production begins. After traveling thousands of miles over months, these beans are about to become chocolate in just hours. Enormous rotating drums hold over a ton of beans, roasting them at 120 to 150 degrees Celsius for 20 to 40 minutes. But here's the art. African beans need higher temperatures and longer times. South American beans burn easily. Light roasting preserves fruity notes. Dark roasting creates robust, bitter flavors. Inside those drums, intense chemistry. The Maillard reaction creates hundreds of flavor compounds. Nutty, caramel-like notes. Those 600 compounds from fermentation transform into over 800 aromatic molecules. The smell is intoxicating. Rich, deep, unmistakably chocolate. Timing is critical. Beans are rapidly cooled with cold air, dropping from 140 degrees to 30 in minutes. Wait even 60 extra seconds and you've ruined thousands of bars with burnt flavors. The roasted beans are encased in inedible papery shells. Metal rollers crack them just enough to shatter shells, without pulverizing the nibs inside, like cracking millions of tiny nuts simultaneously. Then comes winnowing, one of the most elegant processes in chocolate manufacturing. The cracked mixture falls through powerful airflow. Lightweight shells blow away, while dense, oil-rich nibs fall straight down. Modern machines process several tons per hour with 99% purity. What emerges are pure cocoa nibs, small, dark fragments containing 54% cocoa butter and all those precious flavor compounds. The separated shells, sold for garden mulch, cocoa tea, or animal bedding. Nothing is wasted. Nibs enter industrial mills with heavy metal discs spinning at high speeds. Friction generates tremendous heat, 80 to 100 degrees Celsius. This heat ruptures cell walls, releasing cocoa butter. Within minutes, solid nibs transform into flowing liquid. This is cocoa liquor, 100% pure cocoa, intensely bitter and deeply aromatic, the foundation of all chocolate. But here the process splits. Some liquor continues to chocolate making. Much is pressed under 900 pounds per square inch, squeezing out golden cocoa butter. What remains becomes cocoa powder for baking. From one process, cocoa liquor for chocolate, cocoa butter for smoothness, and cocoa powder for brownies. Enormous tanks combine ingredients according to guarded formulas worth millions. For milk chocolate, cocoa liquor, cocoa butter, 40 to 50% sugar, milk powder, lecithin, and vanilla. But the texture? Terrible. Sugar crystals are 100 microns. You'd feel every grain. The mixture passes through 5-roll refiners. Heavy steel cylinders crushing, shearing, and pressing. Sugar crystals reduced to just 15 to 20 microns. Why? Because that's below your tongue's detection threshold of 25 to 30 microns. This is the difference between quality chocolate that melts silkily and cheap chocolate that feels sandy. But the flavor is still rough. We need conking. Massive machines hold 5 tons of chocolate, continuously stirring it at 55 to 80 degrees Celsius. Premium dark chocolate conchis for 48 to 72 hours. Even mass-produced milk chocolate gets 4 to 12 hours. 4 transformations occur. Harsh flavors, mellow and develop complexity. Moisture evaporates completely. Every particle gets coated with cocoa butter for smooth texture, and viscosity reduces for easier molding. Taste chocolate before and after conching, you'd swear they're completely different products. Unconched tastes harsh and chalky. Properly conched is smooth, mellow, and delicious. When chocolate reaches precise parameters, conching stops. But there's one final crucial step. Without tempering, chocolate looks dull and streaky, melts too easily, and develops white bloom. The temperature curve. Heat dark chocolate to 45 to 50 degrees, melting all crystals. Cool to exactly 27 degrees, where stable crystals form. Reheat to 31 to 32 degrees, melting unstable crystals. Industrial machines do this continuously, processing several tons hourly. Properly tempered chocolate has glossy appearance, contracts for easy mold removal, melts at 34 degrees, just below body temperature, and stays stable for months. But it must be molded immediately before it sets. Modern machines fill 1,200 molds per minute, 20 molds every second, each precise to the gram. Polycarbonate molds move on conveyor belts. Vibration tables shake them rapidly, removing air bubbles and ensuring chocolate flows into every corner. Filled molds enter cooling tunnels for 15 to 40 minutes at 8 to 12 degrees Celsius. Cool too fast and you get cracks. Too slow and production backs up. At the tunnel's end, chocolate has solidified and contracted. Molds flip upside down and perfect bars simply fall out. Automated cameras scan every bar for defects. Imperfect bars return to be remelted. Nothing wasted. Perfect bars continue to packaging. A single factory produces 500,000 bars daily. Mega facilities exceed 2 million. Automated machines wrap bars at over 200 per minute. Aluminum foil blocks, moisture, and oxygen, enemies that cause bloom and rancidity. Paper wrappers provide branding and batch codes. Bars become multi-packs, then cases, then pallets. Robotic systems coordinate with precise timing, moving millions of bars through massive climate-controlled warehouses. Trucks deliver to distribution centers. Smaller vehicles reach stores. Throughout, temperature control matters. Chocolate stores best at 15 to 18 degrees. Finally, after months and thousands of miles, that bar reaches your local shelf. You pay a couple dollars and enjoy it in minutes, but it represents 15 processing steps, 3 to 6 months, and hundreds of workers from farm to store. The global chocolate industry, $130 billion, 7.5 million tons annually. But scale brings responsibility. The industry focuses on fair wages for farmers, eliminating child labor, sustainable farming, and ensuring cocoa farming remains viable for future generations. Because without those farmers carefully fermenting beans under banana leaves, none of this industrial miracle would exist. Next time you unwrap chocolate, take a moment. Appreciate the complexity, the thousands of years of knowledge, and the hundreds of people who created that perfect bite. Subscribe for more manufacturing deep dives. If you love chocolate, like our video. What other everyday products should we explore? Let me know in the comments. Now go enjoy some chocolate.